Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Guwahati University of Science and Technology. Today we will take lecture number 14 of the subject of Object-Oriented Analysis and Design, in which we are going to discuss the class diagram, which is the structure model of the project through the UML. Dear students, the class diagram represents the structure model of the unified modeling language, which is very much close to the code or programming of the project. In class diagram, as we provides the data members and member functions which are to be processed by the objects, so these can be easily converted into a programming code in C++ and Java or any other languages. So that's why understanding of the class diagram is very much important through the design perspectives. This is the discussion agenda. It has the topics of UML class diagrams, then we have the domain model class diagram and system model class diagram. These are two different types of class diagrams. Then we have the UML class diagram notations. It's very much important to understand the different notation used for the class diagram. Then we have the UML class notation and binary association used in the class diagram. Similarly, unary association used in the class diagram. Association, aggregation and composition, these are the relationships among different classes in the class diagram. And also we have the inheritance relation, which is also called the generalizations, in which the parent class provides the services to the child class or the child accesses all the capabilities of their parents. Also, we have UML multiplicities in the class diagram, that how many instances can be called from one class to another class, and at the end we have UML class diagram examples. Now, what is a class diagram? Basically, class diagram is an important aspect of object-oriented analysis and design, in which model the class objects in a diagrammatical representation. So class diagrams is a main building blocks of every object-oriented methods, because the class diagram provides us a close relationships of the designs with the code using the classes and objects. So class diagrams shows us different classes with their relationships. Relationship specifies that how one class can be related to another class. Also, interface classes and association and collaboration relations, these are multiple relations used in the class diagram. We have a UML standardization used for the class diagrams. Currently, we are using UML 2.4. Also, we have 2.5 versions, but that is still not the industrial standard so far, but that is just a theoretical standards. 2.4 is mostly used for the industrials, means that software industry standards. Now, class diagrams has many building blocks of an applications, and these are based on the OOPS, object-oriented and programming concepts. So in OOPS we have classes which has the data members and member functions, and each class represents the particular instance of itself, that is called the objects, and through the object we can access the data member and member function implemented inside of the class. Classes, there are multiple classes in class diagram. We can design one or more than one classes in class diagrams. Also, we can in fact provide the relationships of the inheritance, which is a parents and child relations. The parent capabilities are transferred into their childs, and relationships means that we have one or more relation, one or too many, that is multiplicity relationships among the classes in the class diagram, and everything in OOPS have its own context in the class diagram. Now, the class diagram describes kinds of objects which has the static relationship in between them. The static relationship means that because it is in fact provided as a graphically notations, so that's why we cannot compile and run the class diagrams in the general interpreters are compiled like in the C++ and Java. But we can in fact compile the class diagrams in the other tools like visual paradigms and similarly in the Paris of the Luna eclipse. Now class diagrams contains multiple in fact different structures, and each class in the class diagram is called the classifiers. Classifiers contains different classes and interfaces, and also another objects can also be called the classifiers. Because each class represents the problem its own context, that's why it is called the classifiers. The classifier of the systems, that means that different classes having such systems, or it can be called the subsystem or the components, having the different relationship between different classifiers. And each classifiers have the attributes, operations and constraints. Attributes represents the all data members of the class, means that different variables that are implemented inside of the class, and operations represent different functions implemented inside of the class. Also we have certain constraints in the class diagram, means that when one class is accessing the another class, there it must be accessed through certain constraints, and the constraints can be that whether this class is a public, so that's why it can be accessed outside of the project or within the project or within another classes. If it is the private class, then we cannot access that class outside of that particular class. If it is a protected class, so only the children classes can access the parent class, and if the parent is protected, that means that only children is allowed to access that particular class. Some common types of class diagram are called domain model class diagram and system model class diagram. Domain model class diagram represents the domain area of the problem, means that only the domain models is implemented for representing particular area of the projects in which we are going to develop that particular project. But the system model class diagram represents the implementation classes of inside of the class diagram. That means that system model is more relevant to the code of the project. In the domain model class diagram, it provides only the class names and then associated attributes in that particular domain. In the domain model class diagram, there are no functions are in fact mentioned in each class there. You can see that this is the book item class, which is inherited from the book class, and there is no certain functionalities of both classes here, just there are attributes here. Similarly, this is the author class. You can see only name with the string data types and biography of the string data types are implemented here, but there are no certain attributes here. In account class, we have ID as a number, similarly history, and which is the arrays, and open, which is the date data type, and state, which has the account state data types. So you can see that there are no certain functionalities or functions or methods implemented in each class here. Some classes are without even that attributes, because these classes are in fact accessing the other attributes from the other classes. You can see that these two classes are accessing the interface class to the interface realizations relationship. This one is the composition relationship, and here you can see this is in fact the aggregation relationship, while here it is the generalization relationship. We will provide detailed discussion about all these relations in the next slides here in this lecture. So, in fact, in the domain model class diagram represents certain classes where no certain functionalities are implemented. Just you will see that the different attributes are implemented inside of different classes. So you can in fact create the domain model class diagram from the entity relationship diagram of the database as well. Because when you have multiple data inside of your database, so you can convert that database into domain model class diagram with the just attributes here, and each and every attributes are implemented inside of that particular class who will be responsible for implementing that particular attributes. Now this is the system model class diagram of implementation classes, but mostly we use the system model class diagram because it is very much near to the implementation of the project. So in the system model class diagrams, we also provides the attributes as well as the functions here. For example, you can see here that is the M holder is in attributes of the surface holder types, and also there are functionalities of the list of methods which are implemented inside of this preview class. Now you can see that preview class is in fact italic. The reason behind it is because it is an interface class. Well, you can see that Android.view and then scope resolution operator surface view. That is in fact non-italics. That means that it is a concrete class. Now, if we are in fact provided with the interface here, interface is in fact the stereotypes. That means it is the interface class. Well, this preview class is in fact the so it is an abstracts class that is called preview. Now you can see that there are multiple relations among these classes. For example, here we are using the uses relationships. Similarly, this is also a uses relation that this class is using this class. Similarly, this class is also using that particular above class. So here are multiple relationships among these classes. Now in class diagrams, we provide the name of the class diagram first of all. For example, employee is the name of the class diagram. Then the list of class attributes. These are the attributes with the attributes name and the data types used for that particular attributes, like name and string is the data types ID and long is the data types. Similarly, salary and double is the data type of the salary. So this is the in fact the list of different attributes or the data associated with this employee class. Also we have the set of the functions or the methods associated with this employee class. So these are, for example, get name and its return type is the strings. Similarly, set name, and here you cannot you means that there is no return time. So that means that its return time may be above or it may be by defaults. Similarly, calc internal stuff, it will take three different parameters, int x byte and int y decimal. In fact, these are two different parameters. One is the integer and similar second one is also the in fact decimal, and first one is the byte integer. Now you can see that there are minus plus hash and static, that is underlines access modifiers of the attributes as well as the functionalities. For example, minus stands for the private, means that it cannot be accessed outside of the class. Plus stands for the public, that means that these attributes or function can be accessed outside of the class. And hash for the inheritance, means that if this is the parent class, then only this attribute, that is the salary attributes, will be accessible to the child of this employee class, but it cannot be accessed to any other class in the project. And if we have underlined, that means that this is the static attributes. Abstract class name is provided in the italics, while the concrete class names is provided like in the normal written formats, like that is employee. In the class diagram, we have seen multiple relations here. So these relations are represented with certain lines or arrows between different classes here. So first relation is called the association. We will provide you detail about all these relationships in the upcoming slides. So here there is only just their definitions. So in the association, as its name indicates, when one class object is declared in another class, and then through the object we accesses the function or data of that particular class, then it is called the association. So an association is a certain relationship between instances of multiple classes where one class must access the other class functions and data. So for example, clients communicates to the servers. So here we will access the object of the server inside of the client. So then the client will be able to communicate with the servers. And that is indicated by the straight lines or the arrows. Because there are multiple association relationships like the unary association and the binary association. So that's why we will provide straight lines or the arrows here. Another relationship is called the aggregations. It is a special sort of the association where one class belongs to a collection here. For example, when as instructors part of the faculty, instructor is a part of the collection of the faculty because collection contains multiple instructors, so that's why instructor belongs to the faculty. This is a special association where the other class belongs to the collection or the multiple classes here, and it is indicated by the empty dimension symbol on the side of the collection. For example, should be empty dimension symbol towards the faculty here. Another important relation is called composition, which is also in association, but it is stronger than the aggregation. And here the lifetimes of the different classes exist, because when one class cannot exist without the aggregates, then we will say that it is the composition. And it is indicated by the solid diamonds on the side of the collection here. So when one class destroys, then the another dependent class also will be destroyed here in the case of composition. Inheritance is very much simple concepts in which the parent class accesses the data member and member function towards the child class. So that is can be accessed towards the child class. And so in the inheritance, we have the subclass and superclass relationship, and it is also in fact called the generalization, where the superclass is accessible to the other child classes. For example, bird is a part of the mammal, so because the mammal is generalized class and bird is a specific class, so this is the child of the mammal class, and it is indicated by triangle pointing to the superclass. So parent class have the triangle, and the parent class will be accessed to the child class here. Now you can see these are different sort of the arrows between classes which are showing relationships among the classes. The first one is called the association, but it is a unary association. It is not the binary, because the arrow lines shows that the relationship of one class is towards the another class only, while this class cannot access the other class, so only one directional association is provided here. This is the inheritance, also called the generalization relation, which is where straight lines and empty triangles symbols, and this is pointing towards the parent class. This is also called realization or implementation, where we implement the interface classes here or realize the interface classes. This shows that dependency means that one class is totally depending on another. If one class is destroyed, then another will also be destroyed. And this is the aggregation relationship, means that it is pointing towards the collection of multiple classes. And this is the composition relationship, which is one sort of the aggregations where the collection exists, but one is totally depending on another class, and here the lifetime is important here, because when one class in fact is exiting from the system, then another will be affected as well. Now here we are providing you all these relations with the help of the programming examples. First one is called the binary association. In the binary association, both classes are accessing each other. For example, if we have A class and another one is B class, in the A class we declare the private object of the B, that is my B is the object of B. Similarly, in B class, we also have declared the private object of my A, which is in the object of A class. And there are there are functions do something in the A class and operation and service in the B class. These are two different functions and there is only one function. So if we are accessing through the object my B of A function, B function, that is service function, then that means that A is communicating with B. Similarly, B is also communicating with the object of A, and do something function is accessing inside of the B man. So that's why there is a binary association or communication between A and B. So here optionally may create an association class. That means that two classes are associated with each other through their objects. Another important relationship is called the unary association relationship. In the unary association, we only perform the communication from one class to another, but not from the other to first one class. You can see that here minus my B is a private object of the B class, and do something is a function in A, but service, which is a public function, then it is accessed through the my B object. So that is called unary association. Means that only one side communication is performed here. Another important relationship is called aggregation relationship, where the collection member is a relationship. And here you can see that one is the create function and second one is the module function. In the create function, we have declares or instantiated the private object of the module class, and do something is a function here. Now through this we are accessing void do something, and we are in fact also accessing the function of service inside of the create function class through the object of the module here, which are instantiated here. So here all depends on the side of collection is created, because create is the collection of the modules, and here there are multiple modules. So that's why create contains multiple modules, and each modules are implemented here, and we are accessing that module here inside of the create. So here no sole ownership implied, means that here when one object is destroyed, then it will remain provides its functionality still. So that is means that here the another is not affecting when here we destroy any one object here. So that is the aggregation, where the aggregate classes are accessed, and multiple aggregate classes can be accessed here. Another important relationship in the class diagram is called the composition, which is in aggregation, but here the lifetime controls is very much important, that the owner control construction and destruction. Means that classes can be constructed and classes can also be destructed or deleted. And here the part object may belongs to only one whole objects. Now see here the examples of the composition, that the field diamond is on the side of the collection because team contains multiple employees. So here is the field diamond, which is in fact pointing towards the side of the collection, and employee is one types of employees which has their list of attributes and functions. Now, in the team class, we have in fact declares the arrays of the objects. Member 0 is equal new members, that is the first object. Now we can in fact delete that particular objects, that is member 0 is deleted if we have done some functionalities with the member 0, and after performing this functionality then we want to wash the memory, so we have deleted the member 0. That means we have just deleted here. That means that here the particular members will be deleted. So that is the composition where the lifetime controls is in fact important in one class, that we can create or delete the any objects of that particular class, and that is very important concepts here in the object-oriented analysis and design. And another important relationship in the class diagram is called the inheritance, also called the generalization, where the parent class is accessed inside of the child class. The parent class is also called the base class, and the child class is also called the derived class. So here all the capabilities of the parents are accessed inside of the child through the objects. So it is like that class B, which is extended from A, means that here the class B is inherited from A, and when the inheritance is performed, then the B also contains all the members and member function of class A. That is called the inheritance, also called generalization. Now, the generalization or inheritance have multiple types here with us. This diagram represents the single relationship. That means that only one parent of A is existing here for B child. That is called the single relationship. In the standard UML, the arrowhead pointing towards the parents here. This is called the multi-level relationship because there is the intermediate class between A and C. So A is the parent, B is the child of A, but B is also the child parent of C. That means that A has two children, B and C, but C is indirect child of A. This is called hierarchical inheritance relationship because there is the hierarchy that A has three different children. This is called multiple inheritance because C has two different parents, A and B. That means C contains the capabilities of both A and B. And that is called the hybrid inheritance. You can see that A is in fact the parent of B and C, but D is in fact the child of B and C. So here that means that D contains the hybrid capabilities of both A, B and C. So that is called hybrid inheritance. Now there is the multiplicity relationship in the class diagrams, and if there are more than one classes, so there must be the multiplicity relationship among the classes. So first one is called 0 to 1, that means 0 are 1 instances. So the notation L to M means that indicates L to M instances, means that 0 to 1 instance. That means that the one side 0 or 1 instance can be created, means that no instances are exactly 1 instance can be created. 0 dot dot star x or just star x means that there is no limit on the number of instances can be created on the other side of the class, means that there can be multiple instances of this particular class, and 1 means exactly 1 instance can be created, while 1 to star x means that 1 or more than 1 can be created, that at least 1 instance can be created here. This is the example of the class diagram. So here you can see that we have not provided any sort of data types, but the standard one is with the data types. So first we have the customer class. Customer class is in the association relation with the order class, means that both have the binary associations here. You can see that there is no arrowheads. So just straight line, that means that is the binary association, and one instance of the customer class can be created for multiple orders, for zero or multiple orders. Similarly, there is the payment class. Payment class has also the binary association, unary association relationship. That means that only this class can be accessed inside of the order class, and the payment has generalization relationships of the credit, cash, and check classes, which means that payment has the inheritance relationship with the credit, cash, and check, and these are the children of the payment class. Similarly, order details has the diamonds relationships, which is the empty relationships here, and it is the aggregation relationships. That means that it depends on the collections here, and the collection is orders. So order details contains multiple orders here, and also we have the item class, which is in fact the unary association with the order detail class, means that only one set navigations can be performed here. So it is the class name with the attributes and operations here. In the standard UML, you should also provide the data types here, also the access modifiers, and also the list of attributes of each functions here with the access specifiers with the plus, minus, and hash, and similarly the protected relationships and underline, that is for the statics. Dear student, this is the end of this lecture. Here is the reference books for you. If you want to study more about the class diagram, you should study this book, Modeling with Unified Modeling Languages, Concepts, Methods, written by the Rempe and Bernhard. So it is very much good book, and it is published by the Springers. So that's why it is very quality books here. Also, if you have questions, you can ask the question through the email. My email is m.kadim@kust.edu.pk. Also, you can ask through the queries through the KCMS. I will immediately respond to you as soon as I get your queries and emails. Thank you very much.